Hello everyone, my name is Selena, and today I'd like to talk to you about some of the physics behind the Red October. Now you may have heard of the Red October from the movie, The Hunt for the Red October, or maybe the book, or perhaps this is your first time hearing about it. Well, the Red October is actually a very interesting submarine. Now what makes it so interesting is that it has a magneto-hydrodynamic marine propulsion system. This means that it functions without any moving parts, so it's actually undetectable to passive sonar. Sneaky. But wait a second. No moving parts? Then how does it get its thrust? Let's look to physics for some answers. There are three major components that are necessary for this system to work, which are the metal fins, the magnets, and these ions that can be found in the water. At first glance, it's hard to imagine a submarine propulsion system looking like this, but to give you more of an idea, here's a DIY MHD boat to compare it to. Here are the metal fins, the magnets on top and bottom. This is the front and the back of the boat. You can tell because the back fins are taped down. Let's focus on the metal fins for a second. A battery source will be connected to the fins, which completes the circuit. This terminal would go connected to this fin, making it positive, since this is the positive side. And this side would be negative, making this fin negative. As soon as a circuit completes, an electric field is being created going from the positive side to the negative side. This is the electric field vector. Now let's focus on where this arrow comes from. Notice that the magnets on top and bottom both have their north pointing down. This creates a magnetic field also pointing in the downward direction. That's what this vector is representing. Now let's move on to the ions down here. Keep in mind that this submarine will only work in very salty oceans because of the importance of the salt ions. As soon as the salt ions enter from the front of the boat, it is also entering the electric field that was created. This is an interaction. This interaction can be explained using Faraday's definition of an electric field. This equation right here explains that when there is a charge represented by Q and an electric field represented by this E vector, it experiences an electric force. This force causes the positive ions to go to the negative fin and the negative ions to go to the positive fin, since we know that opposites attract. This means that the ions now have a velocity. This will lead us to the definition of a magnetic field. This equation is explaining that when a charge is moving in a magnetic field, it will experience a magnetic force. This force can be found using a simple hand rule where your index finger is the direction of the magnetic field, your thumb is the direction of the velocity of the charge, and your middle finger will be the direction the force is being experienced. Your right hand will be the positive ions, and your left hand will represent the negative ions. I will show you an example. In this case, I'm assuming that we are representing a positive ion, so I will be using my right hand. Now, if we're looking at it like this is the negative end. So we know that the magnetic field, our index finger, is pointing downward. Our velocity of our positive ions are going towards this fin here, so in our case to the right. And notice that the force being experienced is towards the back of the boat. Our magnetic force being created won't be perfectly perpendicular for the positive or the negative, but the sum of these forces will create a net force, magnetic force, going perfectly perpendicular, which in this case means perfectly out the back end of the boat. Now, according to Newton's third law of motion, for every action there is an equal and opposite reaction. In this case, what that means is that as the ions are being shot out from the back of the boat, there is an equal reaction happening to the boat itself in the opposite direction, causing it to propel forward. And that's how the submarine works. Pretty interesting, right? I hope you enjoyed my video. Thank you for watching.